Okay, this is our Chapter 1 review from a Advanced Modeling and Analysis, or PreCalc, for our viewers at home. This is Form 2B, so you should have that out, and you can check these along with me. I'm just going to go through how to work each one. I know it's a little bit fuzzy up here, but you can see number 1, and I'll do the problems here on the right. So for number 1, it asks us to state the domain and range of the relation. The domain is the set of x coordinates, and we have -3, -1, and 0. We have -1 again, but we only have to list that one time. The range is the set of all y coordinates, and that is 0, 1, 4, and 5. And then it asks us if this relation is a function, and the answer is no, because each input value can have only exactly one output value, and we see that -1 actually has 2 different output values. So here it's not a relation, or not a function, excuse me. Number 2, we have a function f of x equals 3x squared minus 4, and we want f of a minus 2. What you want to do is replace the x in the function with an a minus 2. So where I have the x, I'm going to put a set of parentheses and put the a minus 2 in there. And then you have to follow the order of operations. Remember PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. And we do have an exponent right here. That means we're going to have to square that, which would be a minus 2 times a minus 2. If I do the FOIL method, I'm going to get a squared. So that's the first. Outer is -2a, and the inner is -2a, which is -4a. And our last entry would give me +4. So now I have 3 times a squared minus 4a plus 4 minus 4. I'm going to distribute the 3 throughout the parentheses. That's 3a squared minus 12a plus 12. And then we'll tack the minus 4 on there at the end. We can combine these like terms since they're both constants, and we get 3a squared minus 12a plus 8. Number 3, it says state the relation shown in the graph as a set of ordered pairs. So to do that, we just take the points and we write the ordered pairs for each one. So we have a point -2, 2. We have a point 0, 2, and 2, 2. And since no input value has more than one output value, it is a function, and that's yes. You can also do what's called the vertical line test. And as long as you can draw a vertical line through the points and never cross more than one point on a line, then it's considered a function. Number 4, we have an f function and a g function. F of x equals x squared plus 4, and g of x equals 1 over x minus 2. And for number 4, we want to take f of x over g of x, which is simply a division problem. X squared plus 4 divided by 1 over x minus 2. Since we're dividing by a fraction, you're going to keep it, change it, flip it. So keep the x squared plus 4. Go from division to multiplication, and then you're going to flip your fraction, which would give you x minus 2. You'll simplify that by using the FOIL method, first, outer, inner, last. X cubed, first terms. Outer terms would be -2x squared. Inner terms would be plus 4x. And the last term would be minus 8. So there's your quotient. step 5, or number 5, is taking those same terms, or same functions, and this time putting a function in a function. We have g of f of x, and that's the same as saying take the g function and put the f function into it. So you want to start with the g function. The g function says 1 over x minus 2. Where I see the x is where I'm going to put my f function, which is x squared plus 4. So I'm going to take my x and I'm going to put a set of parentheses there because I'm going to replace that with the f function, x squared plus 4, and simplify that. Really all I can do is simplify the denominator and get x squared 4 minus 2 is plus 2. So that's a composite function where you put a function in a function. Number 6, it asks us to find the 0 of the function f of x equals negative 2/3 x minus 8. The 0 is the same as your x-intercept. And to find the x-intercept, let y equal 0. Or in this case, f of x equals 0. So you're just going to solve the equation, negative 2/3 x minus 8 equals 0, and solve for x, and whatever you get is considered your 0 or your x-intercept. I'm going to add 8 to both sides, and then multiply by the reciprocal since I have a fraction here, times negative 3/2. And I get x equals negative 24 over 2, which is negative 12. So my 0 is negative 12. For 7, 8, and 9, for 7, 8, 9, I want to look at the whole graph here. It says graph each equation. So usually I like to put it in slope-intercept form, y equals mx plus b. You can see for number 7 though that we don't even have a y. So the thing to do is just solve for x by subtracting 2, and we get x equals negative 2. That means that this is either a horizontal or a vertical line, and it just depends on which axis it's going through. And in this case, it means a vertical line going through negative 2 on the x-axis. So I just find negative 2 on the x-axis and I draw a vertical line through here. This one actually, vertical lines have no slope, so that's why it looks like this in slope-intercept form. Then for number 8, this one already is in slope-intercept form, where the slope, m, is 3, and the y-intercept is negative 2 here. I'm going to start by locating negative 2 on the y-axis, and then the slope is going to tell me where to find my next point. Since the slope is actually 3 over 1, it tells me to go up 3 points. 1, 2, 3, and to the right 1. And so here are my 2 points to connect. I'm going to draw a line through that. You kind of have a good idea you have it graphed correctly. Since you have a positive slope, it should be going up from left to right. For number 9, I'm going to solve for y, so I can have it in slope-intercept form. I have 3y. I'm going to take negative 2x and negative 6 to the other side of the equation. And when I do that, I'm going to get negative 2x plus 6. I'm going to divide both sides by 3. And I get y equals negative 2/3 x plus 2. Find your y-intercept again. The y-intercept is this time a positive 2. And the slope is negative 2/3. So I'm going to go down 2 points and to the right 3 points. And so my slope should be going down left to right because I have a negative slope. going to finish up this first page by doing number 10. The retail cost of a typical mountain bike was $330 in 1994 and $550 in 1999. Find the slope of the line that through the points at 1994 and 330 and 1999 and 550. So those are just 2 points. That's just our x1, y1, x2, y2. We want to find the slope. The slope is found by finding the difference in the y's over the difference in the x's. So I'm going to do that. I will take 550 minus 330 over 1999 minus 1994. And that gives me 220 over 5, which reduces to 44. So my slope is 44, and that's actually going to be $44, which is the increase. It's an increase of $44 a year in the price of a mountain bike. Number 11 says write an equation in slope-intercept form for the line that passes through the point 4, 1 and has a slope of -1/2. So I want it to look like y equals mx plus b when I'm done. That's my slope-intercept form. I have point A of 4, 1, and the slope is -1/2. To put it in slope-intercept form, I'm first going to start with point slope form, which is y minus y1 equals m times x minus x1. This is going to be my x1, y1, and I'm just going to substitute into the equation. Y minus 1 equals -1/2 times x minus 4. I need to simplify. Y minus 1 equals -1/2 x plus 2, and then add 1 to both sides, and you get y equals -1/2 x plus 3, and that's your slope-intercept form for number 11. Number 12, we want it to write it in standard form. Standard form, ax plus by plus c equals 0. Excuse me, minus c equals 0. And I have an x-intercept at -3 and a y-intercept at 4. And I'm going to give those a point. If I have an x-intercept at -3, that ordered pair is -3, 0. If I have a y-intercept, that ordered pair is 0, 4. So now I have 2 points. I want to put it in standard form. I'm going to start with point slope again. So y minus y1 equals m times x minus x1. I do need the slope for this, so I'll take my points to find the slope. The slope y2 minus y1 over x2 minus x1. It doesn't really matter which one's your x1, y1, x2, y2. I'm going to take 4 minus 0, and then 0 minus -3 gives me a slope of 4 over 3. So that's my slope that I'm going to use, and I'm going to pick one of the